Yeah, welcome back. So we're on week 7 now. Week 7 is sine and cosine applications. Here's new build. So we're just talking about big old Ferris wheels and how we can do these kind of problems. Definitely watch my videos. I got some good videos to help you. And here's another video to help you, which is our submersion one, right? So we're going to skip down to question 3 because that was what was asked for during the Google Meet. Also during the Google Meet, you want to email me your big purchase that you purchased or maybe your family purchased, like a house, a car, clothes, airline tickets. Mine is a air conditioning heating unit. I just found out broke today. Now we have to get one. They're going to install it tomorrow. That's really fast service. But it's going to cost like 10 grand, right? $10,545. It's so much money. It's like half of a car. Or maybe a whole car if it's a used one, not a nice one. Or maybe a nice one. Okay, here we go. So basically we're doing Ferris wheel applications, which is awesome. And so we're in quarter 3, week 7. I think this is 7.1 or 7.2. A water wheel on a paddle boat has a radius of 1 meter. So we're going to draw the picture over on the right side here. We're going to draw the picture. So here's our paddle boat. Has a wheel on a paddle boat. So here's our big boat. Big boat. I don't know. It looks like a car to me, but maybe put a sail. I don't know. What are you doing? I don't know. Here's the wheel though. Erase all the other stuff. That's crazy. Okay, so just picture the wheel. Just draw the wheel. So this wheel is submerged underwater. So that's kind of new. That's kind of weird. So the wheel of the paddle boat has a radius of 1. So we go ahead and draw the center of your wheel. And you're going to do a radius of 1 meter. And also don't forget a radius of 1 this way, 1 meter. The wheel rotates once every 1.46 seconds. So that's actually going to be our period, right? It's going to be our period. 1.46 seconds is our period. That's good to know. And the bottom, 0.3 meters of the wheel is submerged in water. So we have a distance here of 0.3, right? That, wait for it, that it's submerged. Water. That's supposed to be water. Sorry, water. So 0.3 of it is, let's go and do that in red. So 0.3 of that is submerged in water. Cool. Well, what's the other part of it then? That's not in water, but still below the center of the circle. And so if we take 1, which is 1.0, and we minus 0.3, that's going to give us 0.7, which is the distance we need right there. So 0.7 is that distance. Okay, that's important, else you can't really do this problem. So determine the cosine equation of the graph starting from a point at the top of the wheel. What the? So okay, so starting at the top of the wheel, wow, it's going to be up here. So that's different than a Ferris wheel, isn't it? So we're starting at top. So instead of being a negative cosine equation, this is going to be a positive cosine equation. We're starting at the top. So determine the equation. Well, to do the equation, what do we need? We need a blank. We need what the amplitude is. It's going to be cosine, positive. We need the period, or the b value, right? We need the b value, x. And then we also, which is the period, right? Remember the period is equal to 2 pi over b. And then last but not least, we need the, let's see here. In fact, let's see here. So we need the, midline. Is the other blank, the midline. Well, we can kind of, I think we just found the midline, didn't we? Because if this is an x-axis, and this is an x-axis, and so that means that 0.3 is submerged below. So that means that the midline is above, which is 0.7. So we have a midline above of 0.7. Nice. The amplitude is radius. So how high up, how high down? So our radius, our amplitude is just 1. So we have an amplitude of 1 and a midline of +7. So all we need now is what goes in there next to x. So that's our b value. That's our b value. Which again, if we switch a roosie, right? The B will come up here, and the period is going to come down here. So now it's going to be B is equal to 2 pi over B over the period. And they give us the period, there it is, 1.46 seconds. So that means our B value is going to be 2 pi over 1.46 seconds. So that's where we're going to put in our B value. So there's the equation done. Woo! There's our equation done. So there's part A done for question 3. Remember, if you haven't done so, email me. Once you watch this video, email me a big purchase that your family did, and then that'll show that you've been participating with us on this video. Graph the height of the point on the wheel relative to the surface of the water, starting with the highest point. So graph the height on the point of the wheel, starting from the highest point. So the highest point of our wheel, right? So the highest point of our wheel is going to be what? What's our maximum? And so our maximum is going to be up here. And so, well, if the midline was 0.7 and the radius was plus a 1, the maximum will be 1.7. That's our maximum to do our graph. And then again, the minimum is going to be down here at negative 0.3 because it's submerged below the water. And we're going to go ahead and start at the top, and we're going to go ahead and go down. Ready? So we're going to start at the top, we're going to go down, and then your halfway point is whatever 1.46 is, but cut in half. And then back up to the top again. Right? So our halfway point right there, so the full length is 1.46. And then half of that is 14 divided by 2 is 7, so 0.73 seconds. Let's double check. So our full period is 1.46 divided in half, you have 0.73. So 0.73 is where we're halfway through the cycle, basically. Our wheel is already be underwater there. Cool, so there's our graph, you guys. You want to match that on canvas? There's our graph. There's our graph, going from negative 0.3 up to 1.7. Okay, because we added the radius of 1 with our 0.7, our midline. Okay, oh, also, if you didn't already know this, to find these, there's actually formulas. Did you know that, Reagan? Harley? There's actually formulas to these. I don't know if I ever showed this with you. So here's some formulas if you want. So the amplitude, to figure out the amplitude, it is just radius. Or you can do the maximum, 1.7, plus the minimum. And so the minimum is negative 0.3. And then we divide it by 2. And so we're going to do 1.7 with negative 0.3, and then divide it in 2. And that's messed up. And that's actually the midline. I think I messed up. The midline is 0.7, isn't it? Oh, that's the midline. Sorry. So the midline is where you add those together. The amplitude, you minus them. So here's the formula for midline. Sorry. So the formula for midline is the maximum. Write this down. Plus the minimum divided by 2. So that's the midline, The amplitude, that's something different now. That's the maximum minus the minimum divided by 2. So let's see if that works. So the maximum we got, again, was 1.7 minus the minimum, so that's a negative 0.3. And so negative with a negative is a positive. And 1.7 plus 0.3 is 2. And 2 divided by 2 is just 1, which is our amplitude. It works. So again, maximum minus the minimum divided by 2, that's the amplitude. Cool. Okay, last but not least, we're on part C, and then we're done. So how long is a point on the wheel underwater? First of all, is it 2 cycles or 1 cycle? It rotates once there's down the bottom of submerged water, consider the water source to be x-axis. Yeah, just 1 cycle. Okay, so here's a little bit tricky. So we want to know how long the wheel is submerged underwater. So we want to look right here and figure out what that part is on our graph, as well as here. And so if you're an AP Calc or 1050, 1060, you would actually have to take the equation and set it equal to 0, and you should come up with two numbers where it crosses the x-axis at 0. And so that's going to be 1 cosine 2 pi over 1.46, the period x, and then plus 0.7. You're going to have to go ahead and set that equal to 0 and solve for 0. That's crazy. That's crazy. So you'd have to go ahead and minus the 0.7 to the other side. So we get a negative 0.7 over here. Then you divide by 1, which is just still 0.7. And then you'd have to inverse cosine. To get that cosine to the other side, you'd have to inverse cosine to the negative 1. And if you do it on one side, you have to do it to the other side. This is crazy. I'm going to show you the fast, easy way using the calculator, but this is 1050, 1060. This is calculus. So you'd have to inverse cosine negative 0.7 over 1, which is 2.34619. 2.34619, I would round it, equals 2 pi over 1.46. And now we finally get to solve for x. Oh man. And to solve for x, we're just going to go ahead and flip and multiply. So times by 146, 2 pi, and that'll cancel it over to the other side. So times this by 1.46 over 2 pi. Isn't there a faster way to do this, Mr. Newbold? There is. I'm going to show you that next. So 1.46 divided by 2 pi times 2.34619. Oh my goodness. So that's 5.38. So this distance is, so 5.38 is our x value. Wait a second. Something doesn't seem right. Was I in radians? Oh man, I'm going to be so mad. I was in, oh no, it's supposed to be in radians because we're dealing with pi, 2 pi. Yeah, because we inverse cosine to the other side and we're dealing with 2 pi. So that's good to be in radians, good. So 5.38, that's something doesn't seem right. What did we do wrong there? Let's see. Inverse cosine. Maybe I'll write the whole thing out and just do the inverse cosine. No, I think we got it right. Let's see. That could be right. No, it's not right because it needs to be close to 0.76. Or isn't that 0.3 even? Man, you're just going crazy here. First of all, 1.46 divided by 2. I made a mistake, but I caught it. 1.46 divided by 2 is 0.73. So first of all, this should be a 3. Okay. So now we're trying to solve for x. What did I do wrong? Minus the 0.7 to the other side. Then divide by a radius of 1. Then we inverse cosine both sides. And so maybe it was the inverse cosine of negative. Let's see. So let's see here. We're going to go ahead and do our 1.46. I feel like I just messed up somewhere. Times our inverse cosine of. So times our inverse cosine of negative 0.7. We minus that to the other side, so it's equal to 0. I'm going to show you the easy peasy. It's still 5.38. But that can't be right because that's way over here. We're at 1.476. Okay, let's use the calculator because I'm not sure what's going on. So here's the Teeter Peter easy method. If you stuck with me this far, you guys are amazing. I'm going to put extra credit on your assignment. Serious, because this is crazy. Okay, so we're just going to graph this sucker. So we're going to graph 1. It is right side up because we started at the top. So that might make a difference. So 1 cosine, here we go. We're going to go ahead and do the 2, use lots of parentheses, 2 pi divided by 1.46 times x, good, close parenthesis, and then we're going to have a shift up of plus our midline, which is 0.7. Nice. So we're going to graph that sucker, there it is. So I'm going to go ahead and zoom in on it actually, I'm going to go ahead and zoom in, I'm going to do the window, and I'm going to change it between like 0 and 2 seconds. Is 1.46, so that'll kind of show, there we go. And so that's where the wheel is submerged. So here's the easy calculator way. You go second calc, you go to the 0 option, second calc, go to the 0 option, or use Desmos and just push trace. And so here it is, right about there, which is 0.531. That's what we wanted. That's the right answer. So left bound, enter. I'm going to go right below that point, enter. And then I'm going to go back to the gas, push enter. And so when we push enter, it is 0.545. I just lost it, but it was there. 0.545. So 0.545. So that's when it starts underwater. Now we're going to push trace, and we're going to go where it finishes being underwater. So again, we go second trace, second calc. Go to the 0 option. Left bound, enter. Right bound, enter. And then right about there, enter. So 0.9148, we'll say 0.915. So 0.915 is where it finishes being under the water. So if we subtract those, that's going to give us the distance when it was under the water. So 0.915 minus 0.545. I'll still have to figure out trigonometry why it didn't work when we said equals 0 and solve for x. I must have made a mistake somewhere there. Okay, but this is the correct answer. I know that. So 0.915 minus 0.545 is 0.37 our answer. 0.37 seconds is how long it's underwater for. There it is. We finished it. Woo! So underwater for 0.37 seconds. Awesome. Still not sure about the other, it wasn't working there because I know we were using cosine. And we had a radius of 1. And I guess because we were submerged underwater now, that should have worked. I'll keep looking. I don't know what happened there. You're supposed to set equal to 0 and do some stuff there. But use your calculator, use decimals. Okay, you behind the screen, thanks for watching. Don't forget to email me your favorite. I said it earlier. Thanks for watching.